All right, let's talk about something we've all struggled with, trying to explain a really complex system and getting totally tangled up in the details. Well, today, we're diving into an awesome visual tool that's designed to fix exactly that, the Data Flow Diagram, or DFD for short.
I mean, just think about it for a second. Whether it's a giant e-commerce website, a hospital's patient database, or even a company's hiring process, things get complicated fast. So how on earth do you get everyone, from the coders to the project managers, on the exact same page?
Well, the trick is to stop telling people how it works and start showing them. You basically create a map, like a GPS for your information, that shows exactly where the data comes from, how it gets changed along the way, and where it ends up. And that map? That's a data flow diagram.
So here's our game plan. We'll kick things off with that main idea of a DFD as a data map. Then we're going to break down the 4 simple pieces that every DFD is made of. After that, we'll see how you can zoom from a huge overview right down into the nitty-gritty details, learn the one golden rule that keeps your diagrams accurate, and finally, we'll check out how DFDs are used in the real world.
Okay, let's really lean into that core idea. If you imagine your system as a big, busy city, the DFD is your GPS. It doesn't just show you the buildings. No, it shows you all the roads, the highways, and the side streets that your data is traveling on. It's all about the journey.
So at its heart, a DFD is really just a simple, visual way to follow the data. What's so great about it is that it helps everyone, from the super technical engineers to the business folks, see what a system does without getting lost in a bunch of jargon. It just cuts through the complexity and gives everyone a common language to talk about it.
Now for the best part. Every single DFD out there, I don't care how big or complicated it looks, is built from just 4. That's right, 4 simple shapes. Once you know these, you can basically read any DFD you come across.
First up, we have the external entity. Think of these as anything outside your system that either sends data in or gets data out. So, in a hiring system, an applicant is a perfect example. They aren't part of the system itself, but they interact with it by sending in their application.
Next, the process. This is where all the action happens. A process is any step that takes data in and changes it into something new. For example, a process called schedule interview might take an applicant's availability and turn it into a scheduled appointment. And here's a pro tip. Notice the name is always an action verb and a noun. It tells you exactly what it does.
Okay, so what happens when data isn't moving? Where does it hang out? Well, that's a data store. Think of it like a parking lot for your information. It could be a high-tech database or, honestly, even an old-school filing cabinet. In our hiring system, a job database holding all the job listings would be a data store. And last but not least, the data flow. These are just the arrows connecting everything. They are the roads on our map, showing how information moves from one place to another. That application moving from the applicant to the receive application process, that's a data flow. So you've got entities, processes, stores, and flows. That's the whole shebang.
Okay, we've got the building blocks down. Now let's talk about the real superpower of DFDs, the ability to show a system at totally different levels of detail. You can start with this massive bird's eye view and then zoom way in, one level at a time.
And this superpower has a name. It's called decomposition. It's a fancy word for a simple idea, taking one big process and kind of exploding it to see all the smaller mini processes that are hiding inside. It's how you tackle a huge, complex system without your brain melting.
You always start at level 0, which is also called a context diagram. This is like the 30,000-foot view from an airplane. It shows your entire system as just one single bubble, and it only focuses on who it talks to in the outside world. It just sets the scene for us.
So for our hiring system example, the context diagram would be incredibly simple. You just see the applicant and the hiring manager on the outside, sending things like an application in and getting a job description out of one big bubble in the middle called hiring system. That's it.
But here's where the magic happens. When we decompose that one big process, we create what's called a level 1 DFD. This is us zooming in for the first time to see the main things that are actually happening inside the system.
And boom! That single process bubble from before is now broken down into several numbered subprocesses, like 1.0 create job opening or 2.0 receive application. Now we can start to see how data flows between these different functions, and this is usually where we introduce our first data stores too.
So,
As we're zooming in and creating all these different levels, you might be wondering, how do we make sure it all stays consistent? How do we make sure data doesn't just magically appear or disappear between levels? Well, there's one crucial rule for that.
It's called balancing, and it's way simpler than it sounds. It just means that whatever data goes into a process on one level has to show up in the more detailed diagram on the next level down. The inputs and outputs have to match perfectly. It's like the ultimate fact checker that keeps your DFDs trustworthy.
This makes it crystal clear. On the left, you've got a process with two inputs, A and B. The diagram below it, the more detailed view, correctly shows both A and B. Perfect, that's balanced. But now look at the one on the right. The top-level process has inputs A and B, but its detailed diagram below somehow lost B along the way. That's a huge mistake, because it means our map is wrong.
Okay, so we know what they are and we know how to build them. So what? Let's talk about how they're actually used out in the real world, and a few best practices to make sure you're doing it right.
DFDs really come in two main flavors. First, you have the logical DFD. This one is all about the business process, the what. It would show a process and just call it store application. Then you have the physical DFD, which is about the technology, the how. It would get specific and say that store application means saving a PDF file to a server. You always start with the logical to make sure you understand the business, then you move to the physical to figure out how to build it.
And hey, if you're going to make your own DFDs, here are a few quick tips to make them great. First, keep it simple, especially at the top levels. Use clear, consistent names for everything. And please, please, please talk to the people who actually use the system to make sure you got it right. Oh, and try your best to avoid having your arrows cross over each other. A clean map is a readable map.
So when it's all said and done, a DFD is so much more than just a technical drawing. It's really a communication tool. It's a shared language that builds a bridge between different teams, making sure everyone has the exact same picture in their head of how something really works. And that's our whirlwind tour of data flow diagrams. They are a seriously powerful way to bring order to chaos and clarity to complexity. So my question for you is this: what's a complex process in your world, at work or at home, that could really use a clear data map? Give it some thought, because the first step to understanding anything is being able to see it. Thanks for tuning in.